Welcome back to another TwinCAT tutorial. Today we'll be learning how to use structures and enumerations in PLC programming. In the last video we learned about arrays in TwinCAT. Arrays, as we have seen, are a collection of data elements of the same data type. If you haven't seen that video, the link will be on the screen and in the video description. Unlike arrays, structures are defined as a data unit type or DUT that can hold elements of different data types. In today's video, we'll learn what they are, how to create and use them in an application example, and finally, we will see how to create a new structure by extending an existing one. We will also explore enumerations, which are another user-defined data type. We will learn how to create and use enumerations in our PLC programming. Let's begin with structures. A structure is a user-defined or custom data type that combines several variables of any data type into a single logical unit. The variables declared within a structure are referred to as components. You can think of a structure as a container to organize our group of variables that in some way go together. Structures allow us to create modular chunks of organized data that can be repeatedly used in the PLC program. There are many advantages of organizing variables into structures. Most notably, it improves coding efficiency. Using structures to pass data reduces the chances of making errors, especially in a large program where the same variables have to be used in multiple places. For most minor changes, the structures only need to be changed in one place. Using structures reduces the lines of code required to pass data from one place to another. Variables inside a structure can easily be accessed using the IntelliSense, thereby reducing risk of typos or using incorrect variables. Using structures keeps the code consistent. The structure is defined in one place only and can be used throughout the PLC project. It makes the code more readable and easier to understand. We will see this in some examples later in this tutorial. Now let's look into an application where we can make use of structures. Imagine we need to control an industrial batch mixer. The liquids to be mixed are poured into the mixer and is spun at some speed for a predetermined period of time. This mixer needs control inputs for speed and time, and also inputs to start and stop the mixing operation. Conceptually, from a controls point of view, the mixer control would look like this. Imagine the PLC communicates with the mixer control system using some field bus. It can send start-stop commands as well as inputs for speed and duration. On the PLC side, we would have corresponding variables in the control logic to initiate the mixer operation. The mixer also has some outputs by which it reports notification data, like its done bit, error bit to indicate if it's faulted or not, temperature of the liquids, and mixing runtime. These outputs will also be linked to corresponding PLC variables. Let's create our structure to work with this object. First, we would consolidate our inputs and outputs into their own separate structures, simplifying our mixer object. We could instantiate the corresponding input and output structures to link to our mixer object. These structures would be defined such that they contain the various components of appropriate data type that the mixer object requires. The mixer object is a function block that contains the logic for the mixer operation. We will cover functions and function blocks in a future video. In this tutorial, our emphasis is on structures. And finally, we will create a higher level structure called st_mixer, comprising of our input and output structures to represent the mixer. Now that we have our structure ready, we can instantiate this as many times as required for however many mixers we need to integrate in our PLC program. We can do this easily by instantiating an array of mixers. You may recall that we did a tutorial on arrays previously. If you haven't watched that video, the link will be on the screen. Once these structures are created, our declaration should look like this. This is how we would send data to the inputs. So if we have start and stop push buttons wired into the PLC, we can link them using the variables bstart pb1 and bstop pb1. This is how to access its outputs. Imagine we got a new mixer called Mixer Pro. It is similar to the four older ones, but with built-in heat control. From controls point of view, it is similar to the basic mixer, but has additional controls to set heater temperature and to turn heater on and off. We can easily incorporate this new heater control in our existing PLC program by creating a new structure for it. Since it has all the controls of the existing st_input structure, we can create a new structure called st_input pro by simply extending st_input and adding the new variables. We can use this new input structure to create a top-level structure for the Mixer Pro. We will see this in action when we get to the coding part of the tutorial. Next, let's look into enumerations. Before I go about explaining what it is, it might be easier to go through an example first to understand why using enumeration makes things easier. Imagine we are detecting the color of an object and we have to execute different logic depending on the color. One way to do it would be to keep track of the color using an integer by assigning a unique color to each number as shown and using if or case statements to execute specific code depending on the value of the integer. But this approach is neither intuitive nor robust. Here is where enumerations are more helpful. Instead of declaring an integer variable, I have declared a variable eColor of custom data type called e underscore color. This data type contains our 5 colors. The components of this data type can easily be accessed by using the name of the enumeration followed by a period, and then the IntelliSense shows its contents in a drop down menu. Enumerations are declared under the DUT folder as shown. So now we can answer the question, what is an enumeration? Like the structure, an enumeration is also a user-defined data type composed of a comma-separated series of components called enumeration values that is used to declare user-defined variables. The base data type for an enumeration declaration is int or integer data type by default. However, you can also declare enumerations that are explicitly based on a different integer data type, like uint or udent. If no start integer value is defined, then by default, the enumeration value starts from 0, as shown. In this next declaration, the first 3 components receive the standard initialization value starting with 0 for the first one, and the initialization value of the fourth component is explicitly defined differently. In this case, blue equals 8. The following components then receive standard initialization values as shown. Repeating a value is not allowed, as in this example, blue is explicitly assigned integer value 1, which was already implicitly assigned to red. This will lead to compile errors and should be avoided. Next, let's hop onto TwinCAT and apply what we have learned about structures for the mixer application. Structures are created under the DUTs folder. I'll start by making a new subfolder for our mixer. Under this, let's add a type DUT. We will call it structure for inputs. Make sure structure is selected, open. And under here, we'll create our inputs. Now, if you recall, we have 2 Boolean inputs for start stop, a integer type input for speed, and a time type input for the duration or time to run. Now the speed is a percentage input from 0 to 100%. So we could leave it as is, unsigned integer, which will only take positive integer numbers. But I want to limit the user's input from 0 to 100. So what we can do further is define it this way. This way, the input for speed is restricted to 0 to 100. Similarly, we'll create another DUT for outputs. That's our output structure. Now, finally, we can create our main mixer structure. This consists of just our inputs and outputs. And there we have it. Here are the 3 structures for inputs, outputs, and our higher level mixer structure that consists of the inputs and outputs. Now let's head over to the POUs and start coding. Open main. And this is where we can declare our variables and instantiate our mixers, start and stop push buttons. Now, if we had just one mixer, we could do mixer of type this that we declared. If we have subsequent mixers, we could do, then we could do, and so on. However, there is a better way of doing it by using arrays. So I'm going to go ahead and delete this and instead declare our array from 1 to 4 of this type. There we have it. However, there is still a better way of doing it. If you notice, I'm declaring up to 4 instances of our mixers and start and stop push buttons. What if this number changes? In the future, if you have 10 mixers or later it's 12 mixers, instead of coming and changing each one of this, what we can do is declare this as a constant. So let's go ahead and do that. There we have it. Now, since we have arrays, we need a indexing variable. I'll call that I. Next, let's start adding our inputs. Now let's use our newly created instances of mixers. So the way it works is you type the first one by giving the index 1, hit the dot, and it pops its inputs and outputs. So I want to feed all the speeds and durations for all the four mixers. So I'll select in dot, and now you can see all the inputs. So we are interested in the speed. So let's say the first one runs at 50%. Time to run is, for the first one, is 15 minutes, but we don't want to wait that long. We'll just make it 15 seconds instead. Similarly, I'm going to speed up and do the remaining 4. Next, we need a for loop to iterate through all the 4 mixers and assign the start stop push buttons. Next, I'm going to use our function block, which I previously created, which executes the mixer logic. This is not important for this tutorial. We will cover function blocks next time. For now, I'm just going to create a new action under main and call our function block. Now we can download our program. And there we have it. All our speeds and times are loaded. And this for loop is executing our mixers. Let's see how this works. So here I've created a visualization to show how the mixers work. Here you can see the temperatures of the various mixers. Here's the speeds that we put in. And we can go ahead and start. And this thing starts. We hit the stop. And it stops. Of course, it gives you a fault when it stopped. You can clear the fault by toggling the start push button. So let's go ahead and run all 4 mixers. There we go. They're all running. It looks like the temperature is increasing when they run. Oh, mixer 2 is done. Mixer 1 is done. Yeah, they're all done. We can turn them off. And there we have it. We recently received the newest and greatest mixer called Mixer Pro. It's similar to the base model, except it has additional controls for um, heating. So we're going to incorporate that in our PLC next. We're going to call the inputs st underscore inputs pro, and we're going to extend this by using our base model. So under PLC training, duties, mixers, we have our st inputs. I'm going to use this as the base model and extend this. So you see how it says here, this is the new structure and it extends our existing structure. So basically, I don't need to add all the previous four inputs, just the new ones. Next, let's create the top level mixer structure. We'll call it Mixer Pro. So this is just a base structure. Also has inputs and outputs. But for inputs, it will use the new Inputs Pro. Outputs haven't changed, so we'll use our existing structure for outputs. So done. You can save and close these. And we would access the new Mixer Pro, by calling its name. Of course, we have to instantiate it first. So I'll go ahead and we only have one, so I'll just say Mixer Pro. It's of type and now you can see the additional inputs. So this thing needs to run at 85 Celsius. What about its outputs? Has the same outputs. So if you want to see the total runtime, you can see it like this. And there we have it. We have successfully implemented structures, created structures using structures, implemented them in our PLC program, and then created a new structure by extending an existing structure. That's all for this video. In the next one, we will dive into functions and function blocks. If you find this kind of content helpful, please consider subscribing. Thank you for watching and see you guys in the next one.